Hello students, welcome to the Quick Solutions All India AIATS Test Series JEE Advanced 2020 Test 3A Paper 1 Physics. Let's go to question number 1. Question 1 says, at the end of a smooth parallel conducting rail, a conducting wire AB of mass m is placed as shown in figure. There exists a uniform magnetic field B perpendicular into the plane of the figure. Rails are connected through a battery of EMF E. As a switch is suddenly closed at t equal to 0, rod AB of mass m jumps off the rails with speed v. Separation between the rails is L. Then, it's a section where one or more than one option may be correct, so we have to evaluate each and every option. A lot of concepts are involved here. The concepts of Kirchhoff's law, then the impulse momentum theorem, the electromagnetic induction. All these concepts are involved here. So let's proceed now. The question says, as the switch is closed, the jump which is at the end of these rails jumps off with a speed v. And then we have to decide on these four options. The option A says total charge that must have flown through battery is delta Q equal to this much. Option B is also about the charge that has flown. And option C is about total energy dissipated in the process. D is also about the total energy dissipated in the process. Well, if we apply Kirchhoff's law and also the electromagnetic induction, then sum of changes in potential in a closed loop is 0, which means E, and there is, because of electromagnetic induction, some EMF across the rod, that sum of these two is 0, which means the impulse which gives it momentum mv is equal to force into time, integral of force into time. The force will be BIL dt, and this we know will be mv because that's the change in momentum. This gives us integral I dt equal to B and L are constants. So integral I dt happens to be equal to mv upon BL. Now what is integral I dt? This is the charge that has flown through any cross section. So this is matching with option B. The total charge that must have flown through battery is delta Q equal to mv by BL. So option B is correct. Option A is incorrect. Let's evaluate option C and D now. Option C says the total energy dissipated in the process is this much. Well, to find the total energy dissipated, we look at work done by the battery and of course the kinetic energy of the rod. The heat dissipated is simply the work done by the battery minus the kinetic energy of the rod, right? The work done by the battery will be EMF into delta Q. So that means it is equal to E mv by BL. That's the work done by the battery minus half mv square. This is the heat dissipated, right? Let's see if it matches with the options given. It's matching with option C. So option C is correct. Option D is incorrect. We can now go to the next question. Question 2 says, in resonating series LCR circuit containing a resistance of R equal to 240 ohm and a source of angular frequency 90 radian per second, if voltage across resistance is 80 volt and across inductor is 60 volts, then value of inductance is this much, capacitance C is this much. Option B is also about that. And then option C says angular frequency at which current lags the voltage by 45 degrees is this much. Option D is also about the angular frequency at which current lags the voltage by 45 degree. Well, it's a series AC LCR circuit. The concepts of resonance in AC circuits are obviously involved. Now to find the inductance, we use this fact that resistance is 240 ohm and the voltage across resistance is 80 volt. So it means that current I into R. R is 240 ohm and this is equal to 80 volt, right? The voltage across the inductor is I into XL and that is given as 60 volt. Now this tells us that XL by 240 is equal to 60 by 80, which means XL itself is 180 ohm, right? Now what is XL? XL is omega L. So which means omega, which is given to us as 90 radian per second. So 90 into L is 180 ohm, which gives us L itself as 2 SI units or 2 Henry. So L is 2 Henry. Now it's a resonant circuit. We can also find the value of capacitance C, because in resonant circuit omega L is equal to 1 upon omega C. XL equals XC, which means the capacitance C can be written as 1 upon omega square L, which is equal to, in our case, 1 upon 90 into 90, because it's 90 square, into 2 farad. Solving, we'll get it as 1 upon 16,200 farad, which means option A is correct and option B is incorrect. Let's evaluate the other options, C and D. The angular frequency at which current lags behind the voltage by 45 degree. Okay, so if the current has to lag behind the voltage, it means that the inductive reactance is greater than the capacitive reactance, and since the phase difference is 45 degree, it means XL minus XC is equal to R, which means, again further solving, XL will be omega dash into L, which is 2, minus 1 upon omega dash into C. So C is 1 upon 16,200, so that means here it is 16,200 is equal to R, which is 240 ohm, right? So if we further simplify and solve, we'll get a quadratic equation in omega dash. Solving that quadratic equation, you'll find omega dash is coming out to be 60 plus 10 root 117 radian per second, which means option D is correct and option C is wrong. We can now go to the next question. Question 3 says, a conducting wire AB of length L, resistance R and mass M starts sliding down at t equal to 0 down a smooth vertical thick pair of perfectly conducting rails as shown in figure. A uniform magnetic field B exists in space in a direction perpendicular to the plane of the rails. Which of the following is correct for the situation given? Option A says, finally the wire will move with constant speed V0 equal to this much. Option B says, finally the wire will move with constant speed V0 equal to this much. C says, mathematically it will take infinite time to attain the steady and constant speed. And option D says, till it attains the final constant speed, the work done by gravity is greater than total heat dissipation. So let's evaluate each and every option. The final constant speed that the wire will achieve. Well, what happens as the wire slides down? As the wire slides down, there is EMF being produced because of electromagnetic induction, and we can see that as the wire slides down because of the force of gravity, the flux will start increasing, and by Lenge's law a current will be induced so as to oppose that increase in flux, which means the current will be in the clockwise sense, right? So that it opposes the increase in flux which is happening because of increase in the area. Now, if the current is flowing in the clockwise sense, the magnetic force on the wire by I into L cross B is in the upward direction. So on the wire there is upward force which is BIL, and there is force mg. BIL we can also write as BL, and I will be the EMF upon resistance. EMF is BLV upon resistance R, and under the action of these two forces it's falling down with, say, acceleration A. Then we have the equation m dV by dt, the net force in the downward direction is equal to mg minus B square L square V upon R. Okay, so this is the differential equation we get involving velocity, right? Now, as far as the constant speed is concerned, when of course the speed becomes constant, dV by dt term is 0, and the velocity, which we can also call the terminal velocity, which has been called V0 in the options. So V0 will be, when dV by dt is 0, is simply equal to mgr upon B square into L square. Now this is matching with option A, so option A is correct and option B is incorrect. Option C says mathematically it will take infinite time to attain the steady and constant speed. Well, solution, if I just write in simple terms, the equation, the differential equation we have got is of the form dV by dt is equal to A minus BV, where A and B are positive constants. You can easily find the values of A and B. And at time t equal to 0, velocity 0, right? We can do the cross multiplication. dV by A minus BV is equal to dt. If we integrate, putting the limit from 0 to t, here it is 0 to V, we will find that ln A minus BV 0 to V is equal to minus BT, which means ln A minus BV upon A is equal to minus BT, and A minus BV is equal to A e to the power minus BT, which gives us V is equal to A by B into 1 minus e to the power minus BT, right? This kind of solution we get. So when as t tends to infinity, we will achieve the constant speed A by B. So option C is correct. Mathematically it will take infinite time to attain the steady and constant speed. So option C is correct. Let's look at option D now. It says till it attains the final constant speed, the work done by gravity is greater than total heat dissipation. Well, the energy here is being provided by gravity, right? And the work done by gravity is equal to the change in kinetic energy and the heat dissipated in the process. So obviously work done by gravity, as I said, is equal to heat dissipated plus half mv0 square. So it's very clear that work done by gravity is greater than heat dissipated. So option D is also correct. Let's now go to question number 4. Question 4 says, in case of image formation by refraction through spherical refracting surface separating the media of refractive indices n1 and n2, for a given spherical surface of radius of curvature r, there exist 2 points for which all rays, marginal rays also emanating from one point, intersect each other at the other point. Distance of these points from center of spherical surface r. These 4 options have been given and we have to decide which ones are correct. Let's say this is the refracting surface. This side has a refractive index N1, this side has a refractive index N2. Let's, for the sake of convenience, assume that N1 is greater than N2. This will only help us make a ray diagram properly. So let's say this is the center of curvature C, and rays start from here. This is the normal. Since N1 is greater than N2, the rays are bending away from the normal. Let's say they are going like this, and when extrapolated backward, the refracted ray meets here. Let's call it this point as I, this point as O, this angle as angle alpha, this of course is angle I, this is angle R, this angle let's say is beta, and the 2 points are at distance R1 and R2. So this distance let's say is R1, and this distance IC is let's say R2. Now we have to apply Snell's law. The refraction is happening at a spherical surface here. Applying Snell's law, we get N1 sin I equals N2 sin R. Right? This is one equation we have by applying Snell's law. Now let's apply the sine rule in a triangle. So in the triangle OC, let's call this point A. In triangle OCA, we can say by applying the sine law that sine I upon OC, that means R1, equals sine alpha upon R, the radius of the surface, which gives us sine I by sine alpha equals small r1 by r. Okay, let's also apply the sine rule. We are applying sine law in the triangle IAC. In triangle IAC, sine beta upon r equals sine r upon r2, right? In the special case, when alpha equals r and beta equals I, we will get R1 equals N2 R by N1 and R2 equals N1 R by N2. If you look at the options, obviously A and B are correct. So the answers we have got, they match with options A and B. The two positions will have distance from the center of curvature, N2 R by N1 and N1 R by N2. So A and B are correct options. Let's now go to question number 5. Question 5 says, a thin converging lens of focal length f makes real image of a moving point object. When the point object is crossing the optical axis of the lens, its velocity vector makes an angle alpha with the optical axis and velocity vector of image makes an angle beta with optical axis. Then option A says, at a distance of f tan alpha plus tan beta by tan alpha from lens, the point object crosses the optical axis. Option B says, at a distance of f tan alpha plus tan beta by tan beta from lens, the point object crosses the optical axis. Option C says, at a distance of f tan alpha plus tan beta by tan alpha from lens, the image of point object crosses the optical axis. And option D says, at a distance of f tan alpha plus tan beta by tan beta from lens, the image of point object crosses the optical axis. Well, the question obviously involves the concepts of refraction by a lens. So let's draw the lens. Let's say this is the lens and this is the principal axis. Let's say the object is crossing the principal axis like this. This is the velocity of the object, and let's assume that this is the velocity of the image. As given in the question, this angle has been given as alpha and this angle has been given as beta. Let's assume this distance to be x and this distance to be y. Then it's very clear that magnitude of magnification is equal to y upon x. If we consider that the object is moving with velocity u0 and the velocity of image is v, then as the object is crossing the principal axis, we can say that v sine beta is equal to mod m into u0 sine alpha. This is true at the instant the object is crossing the principal axis. And further we can say that v cos beta is mod m square into u0 cos alpha. Well, these two equations give us tan beta is equal to tan alpha by mod m, which is equal to tan alpha divided by y by x. Further applying the lens formula, we have 1 by y plus 1 by x. You know the formula is 1 by v minus 1 by u is 1 by f. So here x is minus u or u is minus x. So 1 by y plus 1 by x is equal to 1 by f. Let's call it equation 1 and let's call it equation 2. Using equations 1 and 2, we'll find that the value of x turns out to be f tan alpha plus tan beta upon tan alpha, which means option A is correct. And if we solve for y, we'll find that y is equal to f tan alpha plus tan beta divided by tan beta, which means option D is also correct. So options A and D are correct. Let's now go to the next question.